I'm Yiming from Tsinghua University. It's my great honor to share our work into the dark, unveiling internal site search abused for black hat SEO. In short, our work introduces a new black hat SEO technique, which is called ISAP, which abuses the internal site search function of a high reputational website to promote illegal services. And we proposed and implemented a lightweight detection scheme for it and found over 10,000 of popular websites have been abused. We also did a systematic measurement study of its ecosystem to uncover its strategies and evaluate security risks. And as advertising platforms usually don't allow to promote illegal services, malicious promoters have found various of techniques for promotion. And one such method is black hat SEO, which abuses the ranking algorithm of search engine to make the illegal promotion content appear in users' normal search results and rank high. And common practices of black hat SEO includes keyword stuffing and link farms and so on. And in this work, we introduced a new technique for black hat SEO, which is called ISAP, which abuses the internal site search function of high reputational websites. It is low cost as it does not require to register new domain names or compromise the websites, but it remains effective for promotion. And the internal site search function could help users to quickly find the resources within one website. For example, you can just enter the keyword, the scholarship, inside one university's website, then click the search button. Then you can get all the relevant subpages of inside this university in the result page. And according to a previous study, this function has been widely implemented among popular websites. But it also could be abused to promote illegal services. The root cause is there is no unified standard on how to implement the internal site search function. So in real-world cases, the website could generate a new subpage of the same domain that both the URL and the result page contain the search keyword. So the abuser can just inject the promotional content as part of the keywords and then search it inside one high reputation website, for example, a university's website. Then he can easily obtain subpages under that popular website. That can turn the promotional content. Once those URLs can be indexed by the search engine, the result may be shown in normal users' search result and even rank high due to the high reputation of the website it abused. And let's see the specific steps of ISAP. First, the promoters need to select a promotion target, for example, a domain for illegal gambling service. Then they generate the search keywords, also called promotion keywords. And besides the promotion target, they always contain another hot keywords that can be frequently searched by users. For example, the Sun City is a famous gambling venue in Macau, so it is suitable to promote the gambling website. Then the promoter finds the websites that are vulnerable to ISAP and generate numerous numbers of the result URLs that contain the search keyword. We also call it flexion URLs in our paper. And to make sure those URLs could be indexed by the search engine, they also found some distribution websites. Distribution websites means the websites that have already been indexed by the search engine, but still can add new external links. So they add the reflection URLs as the external links to the distribution websites, for example, to some blog websites. Then the search engine would be guided to crawl and index those URLs. And after that, when a normal user searches the hot keyword in the search engine, the reflection URLs would be appeared in the search result and even rank high due to the high reputation of its main website. Now the user could see the promotional content and the promotion is successful. And as a new technique of black hat SEO, ISAP has broadly affected various of search engines and well-known websites, but no detection scheme has been proposed for it. And we want to make a systematic study of this new threat in our paper. So the challenge we need to address is how to efficiently and accurately detect ICP from a massive scale of data, like billions of daily URLs from the search engine data site. And to tackle this challenge, we started by doing an empirical study of a ground truth data set. It is provided from the security department from Baidu. It is a leading search engine company in China. It contains user-reported ICP abuse cases, containing both the reflection URLs used for ICP and also normal URLs for comparison. And we made a series of observations based on this data set. For example, we found the illegal distribution websites that used to promote ICP URLs always have a higher number of external links compared to the benign ones, which might be a strategy to increase the effectiveness of promotion. And we also found the promotion keywords, as the promoters need to combine both the promotion target and the hot keywords. So the length of the promotion keywords cannot be too short. And over 90% of the keywords in our data set exceed the length of 14 characters. For the time reasons, more details of the features and discussions could be referred in our paper. And based on the observations we made, we built a lightweight detector of the ICP, which can process billions of daily search traffic data of the search engine in just 2 hours. It contains 2 modules. The first is a URL screener. It is used to reduce the amount of data to be processed. It is based on the features we learned from the ground truth data set. For example, it will filter out the data that with a low number of external links in its distribution website and with short keywords based on empirical threat issues we learned from the ground truth. And it can reduce the scale of data to be analyzed from 60 million to just 10,000. And to further remove false positives, we also built a semantic detector, which is built on BERT. It can first identify the ICP URLs from benign ones based on the semantic analysis of the keywords, and it will further classify the specific businesses that the ICP URLs promote, also based on the semantic of the keywords. And it achieves a good performance on our labeled data set. And this detector has been implemented by Baidu, and during 5 months detection, we found over 3 million of such abused URLs, with over 10,000 of websites have been impacted. As for the businesses that are preferred by ICP promoters, we found they are mainly promote adult and gambling services. And new services like the promotion of a black hat SEO service itself is also active. And we also extracted the promotion target from the keywords, and we found they are mainly promoting their context information as the promotion target and combined with the hot keywords. And the promotion target mainly include domain names, Telegram or WeChat accounts, and telephone numbers. And we also got the user click data from Baidu, and we found the abused URLs we identified were clicked by more than 6 million of users in just 4 days. So this threat has made a significant real-world impact. And to demonstrate the prevalence of this threat, we sampled the detected results from Baidu to test their promotional effectiveness on Google and Bing. And we found the URLs we identified from Baidu also have been indexed by those 2 search engines. And by manually searching the relevant keywords, we found those ICP URLs could also be exposed to users in the search results. And some of them even shown in the first page of the search result. So the impact of the ICP is across multiple search engines. And besides detecting the websites that have already been abused, we also try to find other websites that are potentially at risk. And the idea seems intuitive. We can first find the websites that support the internal site search function. And our idea is to, as there is no unified standard on how to implement this internal site search function, and our idea is to enumerate all the possible search boxes on one website and then filter out the internal site search once based on role-based methods. And then we would check if the internal site search function was vulnerable. We would search a series of keywords in the search boxes and observe the result. If the website could generate a new subpage of the search keyword, and both the URL and the web page contain the search keywords, even if the keyword does not exist in the original website, we would think it as vulnerable. And use such method, we evaluate 3 domain lists, including Trunco Top, edu domains, and government domains. And we found, on average, over 18% of them are vulnerable to ICAP. And we also proposed 2 mitigation measures for ICAP. The first is to use HTTP post for internal site search. And the reason why some websites have generated new URLs contains the search keywords is they use HTTP GET, so they would put the keyword as 1 parameter. So if you use HTTP post, you won't generate such URLs. And the second is for non-existent keywords, just return a 404 error code instead of still generating a result page that contains the keyword. That would be abused for the promoters. And we also released our dataset to help webmasters to understand the problem and check their own websites. And we have reported to both the affected search engines and websites. And now Baidu has implemented our detector and regularly removed the URLs. And Bing have also reported that they have made a fix. And we have contacted with 30 organizations that with the vulnerable websites. And we have contacted 50 organizations with vulnerable websites. And 37 of them have fixed the problem. And we are also working with our national search to connect to more organizations. And that's all for my presentation. Thanks for listening, and I'm happy to take any questions.